Hello everyone, this video is about OSI model from Computer Networks. I have already uploaded few videos for Computer Networks. You can refer if you want to. We would mainly concentrate on those topics which would come in IBPS, SBI, SO, IT Office examination, professional knowledge. So let's continue with the topic today, that is the OSI model. What is OSI model? OSI stands for Open System Interconnection. Okay, it is a layer-based model. Open System Interconnection, it is a layer-based model. Okay, that is, it is organized into layers. The model is organized into layers. Okay, it has 7 ordered layers. Ordered layer means we cannot shuffle those layers. The layers has to be in some order. Let's see what are those layers. There are 7 layers. Layer 1 we call it as a physical layer. Layer 2 is data link layer. Layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is network. Layer 4 is transport, session, presentation, and application. These are 7 layers. You have to remember them by heart. Okay, so this all 7 layers, they are divided into 3 subgroups. 3 subgroup means the layer 1, 2 and 3. The layers 1, 2 and 3, that is the network layer, data link layer and physical layer, are called network support layers. These layers are called network support layers. Network support layers. Okay, and these are called network support layers, and the duty of these layers is to deal with physical aspect of moving data from one device to another. Okay, physical aspect means it deals with physical medium. Physical medium means it can be wired or it can be wireless medium. They deal with physical aspect of moving data from one device to another. Okay, here generally these 3 layers, generally they deal with hardware and software. Okay, where the physical layer is only mostly hardware. Okay, and the network and data link layer, they have both hardware and software. Okay, this is the duty of the network support layers. Okay, and the top 3 layers, that is, I told you there are 3 subgroups. The first group is of network support layer and the second is of user support layer. User support layer, these are close to users. User support layer, and their duty is they are mainly software. These are mainly software. Okay, no hardware is there. These are mainly software. So what is the duty? They allow interoperability between unrelated software systems. Okay, if there are 2 software systems which are unrelated, they make them interoperable, especially the session and the presentation layers. Okay, now what is the transport layer? Transport layer, it is the middle, it is the link between the 2 subgroups. It is the link, the 2 subgroups, it links the 2 subgroups and it ensures, what is its duty is? Its duty is the data sent by the network layer to transport layer or session layer to transport layer, it ensures whether they are in norms or not. Okay, it links 2 subgroups and ensures that what the lower layers have sent is in form that the upper layers can use. That is, the data should be in the form that the other layer can use. So data sent by a lower layer, whether it is used by the upper layer or not, whether it is usable by a upper layer or not, it is the duty of the middle layer. So it is divided into 3 parts. One is the network support layer, and is the user layer, and transport layer is a link between the network support layer and the user layer. And network layer, data link layer and physical layer, they are the combination of hardware and software, in which physical layer mainly deals with hardware. And application layer, presentation, that is application, presentation and session layer, they mainly deal with software. Okay, let's move on to our another example so that you can understand it more clearly. Suppose you have here system 1 and system 2. Okay, they both want to communicate. That is, system 1 want to send data to system 2. Here 1 is sending data to system 2. So our direction of flow would be like this. How? See, this is the application layer. Layer 7 is application. You have to remember it by heart. It is the application layer. It is session, presentation. It is application. It is transport. It is network. It is data link, and it is physical layer. Okay. Okay. Suppose this person has to send a message. S1 has to send a message to S2. Send a message M to S2. So how it would do? See, the message would be first at the application layer, the header would be added. At each layer, the header would be added. Okay, this is the data. That means D6 contain H7 plus D7. Okay, this is the data for D6, and this is transferred to here. This contains H5, D5 contains H6 from here. This whole portion is contained in D5. So this is transferred to here, this is transferred to here. At every layer while sending, the headers are added. So I'll write while sending header or end trailers are added. Okay, so this or end is with trailers. Okay, at every layer header is added and trailer is mainly added at the data link layer. Why it is added, I'll tell you while explaining the data link layer. Okay, so while sending, the header and trailers are added, and why have it mentioned at yellow is it is removed. While receiving, at receiving end, headers are removed. So there may be a question regarding this. Okay, so you have to remember at the receiver's side the headers and trailers are removed, and at the sender's side the header and trailers are added. That is, moving from the application layer to the physical layer, the headers and trailers would be added, and moving from the physical layer in the opposite direction, that is moving from the physical layer to the application layer, the headers and trailers are removed. Okay, and suppose the data is sent from application layer to the physical layer over here. Here the data is in the form of digital signal. It would be converted into electromagnetic signal in the transmission medium, and it would be again converted into digital signal. Okay, and while moving upwards, the headers would be removed. The yellow thing is the headers, so headers would be removed. Okay, and the final data received by S2 would be D7. Okay, this is how the transmission takes place. Now let's see the layers in detail. Let's see the physical layer. This is how the physical layer is. This is the sender side. This is the sender side. Okay, and this is the receiver side. This is the sender side, receiver side. Data is coming from the data link layer. It is the first layer. So layer above it is data link layer, and here it is going to the data link layer. Okay, this is how it is. Here it is digital signal. It is transformed to electronic signal. We are concerned with the transmission medium over here. Okay, let's see what are the functions or what are the responsibilities of physical layer. Okay, first is physical characteristics of interface and medium. The physical layer defines it defines the characteristics and interface between the devices and the transmission medium. It also defines a type of transmission medium. Okay, here it also defines which type of transmission medium is there, whether it is wireless or it is wired. Okay, this is what is the first, and second is the data rate. The physical data rate, or you can say the transmission rate. You can say it as a transmission rate. It controls the transmission rate. Okay, this is in the hands of physical layer. And third is synchronization of bits. The sender and receiver not only must use same bit rate, but also must be synchronized at bit level. Okay, that is synchronization at bit level. Okay, so use same bit rate. Check whether they are using same bit rate. Okay, it is synchronization at bit level. It is there in the physical layer's responsibility. Second is line configuration. In line configuration, you would be seeing whether it is point to point or it is multi-point. Okay, point to point means there is a dedicated link between two devices. This is point to point. Okay, multi-point means there is a link, and then those links many devices are connected. If you have any problem, I have uploaded a video regarding this. It is in the part 1 of computer network. You can consult that. Okay, and the second is physical topology. There are four basic topologies. This is also I have made a video. You can see what it is. So what is the topology and how they are communicating, it is also a responsibility of physical layer. So you can see it in the video. It is in the second video. Okay, and next is the transmission mode. So transmission mode, it is of two types, that is simplex, half duplex and duplex. So for this also I I have made a video, you can consult. Also, these are the responsibilities of physical layer. So in this, the main thing is you should concentrate on line configuration, topology and transmission medium. For all three of this, there is separate video, okay? So you can go through this. Next, move on to the next, that is a data link layer. Okay, I told you there is the trailer in the data link layer, okay? The header which is added from the network layer at the sender side, okay, would be removed. Here the header is added and here it would be removed. Here it be removed at the receiver side. At the receiver side, okay. It would, the next layer is the physical layer, okay, and the previous layer was here the network layer. Here the next layer would be network layer and the previous layer here was the physical layer. Okay, here the data was in the form of bits. Okay, data was in the form of bits in physical layer. So what would data link layer do is it would change the bits into data is the form of bits in the physical layer. In data link layer, the data would be in the form of frames. Data would be in the form of frames. Okay, and the trailer is added because in data link layer extra trailer is added for error control. For error control and flow control. Okay, let's see what are the responsibilities of data link layer first so that it is clear for you. Okay, so see, in the header of data link layer we would having source and destinations, sender and receiver address. Okay, header contains sender and receiver address, sender and receiver's address, and the trailer contain, and what does the trailer contain? Trailer contain the information for error and flow control. Okay, let's see what are the responsibility of data link layer. The first is framing. As I told you, the framing is done, that is data is divided into frames. The data link layer divides, it makes streams of bits into frames. Streams of bits into frames. It is the main responsibility of data link layer, into frames. Okay, and second is frame is a data. It is a data unit. You can call it as data unit. You have to remember that frame is a term for the data unit at data link layer. Okay, you have to remember that. And next is the physical addressing. Physical addressing, what we call is MAC address or machine address, or I'll write it as machine address or Ethernet address. It deals with all these, or Ethernet address. Okay, if the frames are to be distributed to different systems on the network, the data link layer adds a header to the frame. Okay, as I told you, it adds a header to the frame. It contains the sender's and the receiver's physical address. Okay, data link contains the physical address, sender and receiver's physical address. And third is the flow control. For flow control, we added a trailer. Trailer is added for flow control. For error control also trailer is added. Okay, and access control. These things, when two or more devices connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. Okay, that is what I have said. So it decides which device would access the link. Okay, for this we have CSMA CA and CD. This is collision avoidance and collision detection for carrier sense multiple access. So I would make a special different video for this also. So you have to just remember the data link layer is responsible for error and flow control, and trailer is added for these, and access control is when two devices are accessing a shared medium. When two devices are accessing a shared medium, so access control is deciding which of these devices would access that medium. Okay, and physical addressing is in the header it stores the physical address of sender and the receiver. And framing is streams of bits, that is number of bits are combined together into a frame. Frame is a data unit which is used in data link layer. That's all about data link layer. Next, move on to the network layer. In network layer also we have, okay, one more thing about data link layer which I forgot to tell, that in data link layer we have node to node delivery. You have to remember that data link layer we have node to node. I'll write it somewhere over here. Data link is node to node. Node to node, or you can call it as hope to hope delivery. Hope to hope delivery is in data link layer, and there we had frames. Okay, you must remember these things here. Okay, now come on to the next, that is a network layer. In network layer we have source to destinations. Okay, source to destination, that is host to host delivery is there in network layer. Host to host. Okay, that is source host to destination host destination. Okay, so it is there. Data link, there is only two main responsibilities of data link layer. That is, first is logical addressing. Logical addressing is IP addressing. This is the logical address, that is, it can change. Okay, this is the logical addressing. And second is routing. Okay, routing of packets from source host to destination host. Source host to destination host. Okay, so in this case the header contains the IP address or logical address. Whereas in data link layer it contains MAC address or physical address. Okay, you have to remember this thing, don't forget. And data link layer you add frames, and in network layer you add packets. Okay, and the responsibility of network layer is routing those packets and logical addressing. Okay, this is okay. Then next move on to the next layer, that is the transport layer. Okay, in the transport layer we have segments. Okay, now you have to remember, transport layer we have segments. Okay, so you have to remember one more thing. In transport layer we have process to process delivery. Process to process delivery. Okay, you have to remember these terms. What is node to node, what is host to host, in which layer it is process to process. You have to all remember this. And in transport layer the data unit used is segments. In network layer it was packets, you have to remember that. And in data link layer it was frames, you have to remember that also. Okay, this is same. Say the upper layer for session transport layer is a session layer, the lower layer is a network layer. So this is a sender side. This is a sender side and this is a receiver side. Okay, here we would remove these headers. Whenever we would be moving to the receiver side, the headers are removed. So what would go to the session is only the D portion. Only the data portion would move to the session. This is how it is made. Okay, is it fine? So let's see the responsibility of transport layer. It is segmentation and reassembly. What you would do is it would convert the frames to segments. This is single frame. Frame 1, frame 2, frame 3. Frames to segments. Okay, it converts the frames to segments, or every segment has a segment offset. The message is divided into segments. Okay, and each segment contains a sequence number. Each segments contain a sequence number. Okay, so through these sequence number we can organize the segments if they are lost. Organize if they are lost. Okay, this is what about this. In transport layer also we have flow control and error control. Flow control and error control. But in this the flow and error control is end to end, not in the network. It is the process to process flow and error control. So whenever it is asked a question, which layer is responsible for end to end error control? So it would be transport layer. And if it is asked which layer is responsible for flow and error control, then it would be data link layer. So you have to be very alert while answering the question, while reading the question also. So this was all about data link layer. Next is the session layer. Okay, in session layer is mainly responsible for two things. One is dialog control, another is synchronization. So we will see how this is doing these two things. Okay, the session layer allows the system into a dialogue, two systems into a dialogue. That is, two systems can communicate with each other. They can they can communicate with each other, and if dialog control means it controls whether this dialog would be half duplex or full duplex. Half duplex or full duplex. It controls That is called what is called dialogue control. If two system was to communicate, so it would decide whether it would be half duplex or full duplex. Okay, types, the way the system could communicate, it would decide. Next is synchronization. Okay, so sorry. Next is synchronization. In synchronization, it is like process to add checkpoints. Suppose you have, let me tell you what is synchronization first. Okay, if a system is sending a file of 2000 pages, okay, we have 2000 pages. And you want to send this, okay, so for after every 100 page, I'll put a checkpoint. Okay, after every 100 page, I'll put a checkpoint, so that after every 100 page, I'll get an acknowledgement. Okay, that is what synchronization is. Suppose you want to send 2000 pages, so you can't send all the 2000 pages at once. So what I did is, after every 100 pages, I put a checkpoint. Okay, and this checkpoint means after this checkpoint I should receive an acknowledgement. So I would be receiving acknowledgement when the 100 pages are delivered. Okay, when 100 pages are delivered, 200, then 300, then 400, then 500. For every 100 pages there would be some acknowledgement for me. So suppose after sending around 5 frames, so 1, 2, 3, 4, 5, so 500. After sending around 500 pages, the system crashes. Okay, so I will have acknowledgement. For 500. Acknowledgement for 500 pages. Then I'll send only the remaining. Then will remaining only send. Remaining only I will send. Okay. So this is the use of synchronization. Okay. Suppose you have after the system gets recovered, so I will send from the 501 to 2000 pages. Okay. I'll not send the pages previous one, because I know it has been received. So there are some synchronization bits. The figure which is shown in blue color is for synchronization. Okay, this is for synchronization. The blue color is for synchronization. That is, after some unit of time, there I would be putting some checkpoints. This is checkpoints. Okay, these are checkpoints. Okay, this is all about the session layer. Let's move to the next layer, that is the presentation layer. Presentation layer, it mainly does 3 things, that is translation, compression and encryption. So translation is, it involves encoding schemes. Okay, you must be knowing about line, bipolar. So for 2 different systems, the encoding schemes would be different. So presentation layer translates it. So that is translation. Now what is encryption? Encryption is to carry sensitive information. System must be able to ensure privacy. So it is used for privacy. Encryption is used for privacy. Means the sender transforms the original information to another. It is for data security. It is for data security. Okay, suppose I want to send message M, so I will transform that message to something M dash and I will send it. Okay, I will send it. On the receiver side, we would decrypt this M dash to M. Okay, so this is encryption. We would transform our message into something else. Okay. Okay, and third is data compression. It would reduce the number of bits. Transferred. It is compression. Okay, the number of bits. It can be text, video, or audio. Anything. It can be text, video, or audio. Anything. Okay. Okay. In presentation layer, what would be asked is, so you should be know about JPEG, Joint Photographic Expert Group, MPEG. Should be knowing about MIDI, you should be knowing about. So these are the compression standards you should be knowing about. So presentation mainly it involves translation, encryption and compression. You have to remember these things. Okay. Our next is the application layer. So application layer, it's already displayed. It allows access to network resources. Now what are the network resources? Network resources like files and virtual terminals, network level virtual terminals, all these things. That is it provides services to the user. You can say it provides services to the user. Services to user. Services to user. So first is the network virtual terminal. The first is the network virtual terminal. It is a software version of physical terminal. Okay. What is it? Is a software version. Okay. What's going on? It's a software terminal of physical terminal. Okay, you have to remember that network virtual terminal is a software terminal. It is physical terminal. It is used for remote login. You all must have used TeamViewer, no? It is like this only. Example is TeamViewer. TeamViewer. Okay. Okay, and the next responsibility of the application layer is file transfer and access management. Okay, that is email, all these services, these come in application layer only. File transfer, access management, and mail and directory services. Okay, basic mail forwarding and storage. Mail services, basic mail forwarding and storage. And I'll write it. Basic mail forwarding and storage. Example is you can have Outlook. Outlook is the example for this. Okay, and directory services is it provides distributed database sources and access for global information about various objects and services. Okay, this is directory services. And file access and management is application allows the user to access files in remote host. Okay, I'll write in short, can access file to remote host. It is the same as virtual terminal only, remote virtual terminal only. Okay, so this was all about application layer, OSI model. Before that, a short revision I would be giving to you, which will about the important topics. I'll write it over there. Okay, first is for physical layer. Physical, you have data in the form of bits. Okay, and the second is data is in the form of bits, and in the physical layer you would be using repeaters and hub. Okay, you should remember this. Okay, second comes the data link layer. In data link layer we have frames. Okay, and we have here node to node, node to node, or hop to hop delivery, hop to hop delivery. Okay, you need to remember this. And here we have bridge. Here we have bridge and switches as the devices. Okay, third we have network layer. Okay, you should remember these things by heart. It is very important. In network layer we have packets. In network layer we have network layer, transport layer we would be having packets. Network layer we have datagrams or packets, both are same. Datagram of packets. Okay, it is in the network layer, and here would be using router. Okay, second is transport layer. In transport layer we will be talking about segments. Okay, here it is process to process delivery. Process to process. Okay, in network layer it is host to host. Okay, all these things are very, very important. You have to study for your exam. Okay, mostly one question would surely be there from this slide only. Okay, so thank you. This was all about computer network OSI model, and please subscribe for further updates.